Welcome back to Command Line TV. This is episode 3. Today we're going to talk about wildcards and text processing using pipelines. First of all, do we have any follow-up from last time?
I did have a question about accessing files, especially when it comes to their extensions. We did access a .gz file, and I was curious, one of the other files we had was a .tar.gz.
Right.
And I was curious as to which one was the actual extension type.
Yeah, so first of all, extensions in Unix don't mean quite as much as they do on other systems. They are primarily there for humans, and the system can work, most commands at least, can work perfectly well with whatever extension you want to give it. So when you have a file like this tar.gz, what's happening there is that it's one type of file, which is a tar. Tar is an archive file, kind of like a zip. But what's interesting about tar is that it's not by itself compressed. All it does is it packages up a bunch of files so that it creates one file. And then you can compress that separately. So that's why it gets two extensions. The tar means that it's archived files, and the gz means that it's compressed. And so they go in that order. But extensions are really not as meaningful as on other systems. So for example, if I want to rename that to something else, and I can still use it as a compressed file. Or another pretty shocking example, last time I think we looked at the PNG file. We did an external viewer to open up the PNG. So that was in Think Java Figs. And I have this PNG, so we did xdg open gridworld.png to look at this file, and it pops up in a separate viewer here. But that viewer actually doesn't, and even xdg open itself, it doesn't care that it's a PNG extension. I can rename that file. So to rename a file is mv. We're going to learn a lot more about mv probably in the next episode. And then I rename it so that it has a .txt extension. So it looks like that would be a text file, but when I do xdg open on that, it still opens up the image viewer. It still knows that it's an image. So that's a little bit odd. The way that it knows that is that it actually looks at the content of the file rather than the extension. So there's a command that does that too, called the file command. When you run file on a text or on any type of file, it looks into the file content and identifies what's there to tell you what it is. And so file knows, even though I called this .text, it knows that it's a PNG image and it has its dimensions and everything else about the image. So that's pretty useful. For that tar.gz that you mentioned, if I run the file command, it says that it's just compressed data. It doesn't actually decompress to see what is there behind the compressed data.
So you just did ls star.png. I know that star is one of the wildcards. What are other things that this star wildcard is capable of?
Right, so star, the idea is that it matches file names. And star can match any number of characters, including 0 characters, and including characters that seem like they would be special, like dots. So a very common way to use it is with an extension. So star.png means anything followed by a .png, and we know that works. But you can also use it in some other interesting ways. So if I want to see every file name here that has an A in it, okay? So I could say ls star A star, right? And this means that any characters come before an A and any characters come after an A. And both of those stars could match emptiness, so it could start with an A or end with an A. And we get a subset of the files that were listed, just the ones that have an A in them. Or if it's just A star, then that's any file name that starts with an A. So you don't have to do it just along the lines of extensions. Like you might think it only works with star.png or something like card.star. Those work fine, but you can also use it in more flexible ways.
Besides star, are there any other wildcards that exist?
Sure. Some of it depends on what shell you're using and how it's configured, but I'll give you two more of the basic ones that are always available. One is the question mark. So like a star, a question mark matches characters, but it only matches exactly one character, not 0 or more characters. So you can use it to just substitute a missing character. And a great example of that is I have files here that have numbers in them. So list 1, list 2, list 3. So if I wanted to match all of the list files with any number after them, I could say list question mark dot fig, like that, to get anything where there's one character following list. Or it could be list question mark dot star to mix and match both kinds of wildcards. So that question mark matching one character is useful in lots of situations. You can also pile them together a little bit. So if I wanted it to match multiple characters, but a specific number of them, like 3 characters, then I could put 3 question marks. So let's say, for example, list star dot 3 question marks. So the star will match anything that's actually going to match my numbers. And then the question mark matches one character, but it does that 3 times. So that will get any file that starts with list and has a 3-character extension. But it would not work if there was a 1-character or 2-character extension.
So the star could be used to search for things that you have unknown lengths for, and the question mark is used for more precise queries?
Yeah, I think so. If you know exactly that it's 1 character or how many characters it needs to be, then that's useful. One great example is when you're doing C programming. So I'm going to go over here to a little C program that we've got. So C programs usually use the extensions .c and .h especially. And those are single character extensions, so you can do something like question mark to just pull out those single character extensions. It turns out that every file in this folder is a single character extension, so it matched all of them. But if these were interspersed with other files, then they would allow me to select just those. That leads me to the third kind of wildcard which we can do today, which is the square brackets. So when you put square brackets into a file expression like this, then you can put individual characters that would match. So if I only want to match files that end with a C or an H, I put the CH in brackets, and that matches just one character, but like the question mark, it's just one character, but the character has to be one of the specified characters. So this would match the C and the H, but not the .o. You can switch the order of these two, and that won't make any difference, because it's just any character from this set, so the order within that set doesn't matter.
I know that besides the square brackets, we also use the squiggly braces as a wildcard. What's the function and purpose of that?
It is a little bit of overlap with what we've already seen, but it works a little differently, so it's important to understand the difference. So if I use squiggly braces here, I can specify different possible extensions. And the way you do that, they can be more than one character, so we are going to separate them with commas. So if I did something like C, H, then that would match anything that ends in a C or ends in an H. So that is the same as doing with square brackets, no more power. But let's go look at some other files up here. So I've got a bunch of files that start with config, right? config.star. There are 4 of them. And if I only wanted the .h and the .log, then I could use the curly braces to specify h, log here. and it would only match those two.
So far, we've used wildcards with the ls command. Can wildcards be used with other commands that we've learned so far, such as more or less?
Yeah, definitely. So wildcards can be used with any command. In fact, the wildcards are expanded by your shell program, the program that is interpreting all of your commands. So that means they can work with commands that aren't even programmed to use them necessarily. So let's try it with a couple other commands. So cat, we know, can show the contents of a file. So if I do cat this config.h, it'll dump out those contents onto my screen. If I give it multiple files, using, for example, the curly braces, it will just dump the contents of both of those files out. And of course, that's scrolled off the screen, but then I can pipe it into more or less. And so I'm first getting the config.h, and then later on, somewhere, I'll get the config.log. So it can cat both of those files at the same time. A command that we learned last week that does something especially useful with multiple files is head. So if I do head on config.h, you remember what head does?
It just shows the intro to that file.
Yeah, the first 8 or 10 lines, whatever that is. And we can specify an option here to make it shorter or longer. But you can also give that multiple files. So if I said config.star here, this is pretty cool. It actually puts a little header with the file name, and it gives me 3 lines from that file, a blank line, and then the next file, and 3 lines from that file, blank line, and so on. So it's showing me like the top couple of lines from each of multiple files, and the multiple files are just based on the wildcard.
Using head, we were able to find out what the top 3 or 4 or 5 lines of each file had. What if instead we wanted to search throughout those files for particular words or phrases?
Great, there's a perfect command for that you're going to love. This is one of the most powerful Unix commands that is accessible to a beginner. And it's called grep, G-R-E-P. What you do with grep is you specify a word or a pattern of some sort that it will search for in files. So let's say I want to search for a word like copyright. And the files I want to search in are what I put next. So you could list multiple files here like that, or you could use your wildcards to specify which files. What if I just put star all by itself? That'll match any file at all in the current directory, right? So I want to, this command says I want to see occurrences of the word copyright in any file in the current directory. And so what this output does is it shows us a file name. So for example, there's a file called makefile. And then in that file, it's showing me only the lines that match the word copyright, okay? So the makefile seems to have 4 lines that match that. And then there's another file called makefile.am, which has 1 line that matches that, and so on. The readme has 1 line that matches that. So that's the basic structure of grep.
Now, the grep command you just put out dumped a lot of content onto the terminal. Is there a way to better organize or view everything that we're trying to see?
Yeah, one thing is that it paged off the screen, so we have to scroll up to see some of it. And of course, we know how to do a pager so that we could do like pipe it to less, and then you only see 1 screen at a time. That's part of it. But something else really cool that you can do is grep, at least the version of grep from the GNU project, which we mentioned last time as well. Grep supports coloring its output. So if you say ~color, then it will give you this colorful output where the file names are in purple, the text you are looking for is in red, and then the rest of that line is in black, like that. And that just makes it a whole lot easier to see the different matches that you've got.
So like most of the commands that we've learned, it seems that grep has a case sensitivity issue. Is there a way to work around that?
Yeah, you notice here that I typed copyright with a capital C, and all of the matches it's giving me are also a capital C. If I searched for copyright with a lowercase c, it would also search for matches, but let's also keep the color. There are ways that we can specify that we always want color output, but I'm not going to get into them right now, so I'll just remember to put that double dash color there. So when I use lowercase copyright, it's finding instances where copyright appears in lowercase, and those are different than the uppercase ones. So yeah, it is case sensitive, but I can put a -I, which means that it will do an insensitive search. So now it will give me every match of copyright. Some of them are lowercase, as in here, and some of them are uppercase. And I think there are even ones, if I search up a little bit, that are all caps. Yeah, like here it appears in all caps, which we didn't get it by just doing a capital C or a lowercase c, but it matches that too.
I noticed that the last two lines that your terminal put out didn't seem to put out anything in regards to copyright that we searched for.
Yeah, these are errors or warning messages. The last one here, grep can search through binary files as well as text files, but it's not useful to show you the lines of a binary file because they won't be understandable. So it just says that it matches without showing me the line where it matches. So that explains that one. These other ones, which also appeared sprinkled throughout up here, when I specified star matches everything in the current directory, but that includes other directories. So grep by default doesn't descend into those directories, and it doesn't really search in a directory on its own. So it just gives me a warning that one of the file names that I included here by typing a star, it's not going to look at. There are two things I can do about that. One is to just silence those types of messages. So there's an S option. You can either go separately, or like we did with ls-ltr, you can merge that in with another switch. So I and S are both different options that I'm specifying here, but they're all part of the one dash. So S means to silence any error messages. And if I do it that way, then it doesn't say anything about those directories, it just silently ignores them. So that is a little bit of a cleaner output. The other option is you can actually ask grep to look inside those directories and grep through all of the files within them. So when you do that, you specify a -R for recursive. And now we're going to see lots of files that we didn't see before. And some of them, they'll be specified here with / in them, which means it's in a subdirectory. So previously it just ignored the source folder, but now it's going in there and looking at all the files in there and also searching for copyright. So that allows you to search many, many more files very quickly.
Well, now that we used grep to search for any instance of copyright, it puts out a lot of data. Is there a way to tell where exactly within the file that line that we search for is?
Yeah, that's a great question and very useful. There's a very simple option we can add to grep, which is -n. So again, I can keep it as part of this same block or make a separate -n. And what this will do is it adds a number after each file name here. That number tells me what line number it appeared on in that file. So you can see that in this one file, hello.c, copyright appeared on line 3, but then it also appeared down in 167, 180, and 183. So it gives you a sense of whether all of the instances appear in the same place or are they spread out more, stuff like that. There are a couple of other cool options related to changing the output style. One of them is, let's say that I only want to see what files matched. I don't really care to see the text of the line that match. I just want to know which files match. So that is an option called L or -L. This is a lowercase l, and I'm not going to do the recursive anymore, but I'll turn the S back on, which means suppress the error messages, right? So -L will change this to be much simpler. It's just going to give me a list of file names that contain that word copyright. It doesn't show me where it matches, and the file only appears once in this list, even if it has multiple occurrences of that text, the copyright word. So let's try to search for a different word, and we'll see a different set of files that match. Let's try something like printf, and we still see printf in many of those files. If you want to go back to the style of output we had before, we can just delete the -L, and now we will see where it matches. A lot of these are matching capitalized versions of printf. So if I wanted to see, does lowercase printf appear in any files, or which files it appears in, I'll get rid of the -I and just keep the L, and now it appears in all of those, and here are some of those. So Grep is a very powerful tool just for searching for text within a file. So in addition to that -L, which just prints the file names that match, there's one other option that's really cool, which is -C, lowercase c. And that means to print a count of how many matches within the file. But again, it doesn't show us the lines that match. It just shows us the counts. So that looks like this. What's happening here is it has a file name, and following that file name, it puts a number, which is the number of times that matched. I believe it's actually the number of lines that matched. So if the word printf appears on the same line twice, it only counts once.
I guess this is a good place to mention that, like all the other commands, you can use the ~help option with grep.
Definitely. So grep has lots more options to explore, and if we do ~help and less like that, then we get to see some more of the options that it supports. Another small tip is that if you have a phrase that you want to search for rather than just a single word, remember that spaces are significant in command lines. So if I put spaces around it, like let's say I want to search for free software in all of the files. The problem with that is it interprets the first parameter here as what you're searching for and the rest as file names that you're searching in. So there is no file called software, which means this is going to be a problem. So to do that, I can use quotes. Same way that I quoted spaces in file names. So I can use quotes there to group together free software as one thing that I search for, and then wherever that appears will show up. But I need the quotes to group it together like that.
So today we went over the wildcards as well as a lot of features that grep has to offer our Linux users.
Yeah, and next time I think we will look at a few more of the text processing commands. There's a command called cut and sort and unique. A lot of data in Unix systems is kept in plain text files, and these commands will allow us to process them and search them in particular ways, and they all interact with each other very nicely. We may also look a little bit at renaming files using the move or mv command, which came up a little bit today. So we'll go into some of the features of that as well. So join us next time.